literally
Sure.
in a minute or so. Yeah.
Yep, that's all great.
Yeah. And we do have Andrew here as well. He's joined us.
That's great. Thank you.
Yep. Yeah, I'm definitely here.
Good morning, all, or good afternoon, or good evening, depending where you are in the world. So, thank you for joining our webinar today. And I'd like to welcome you to this week's Virtual Open Week. And today's topic will be our lecturers' insights in exploring EIT's electrical engineering and renewable energy options. So we'll be lucky enough to hear from our lecturer, Dr. Hossein Tafti, and we'll also be getting insights from Andrew Packness, which is one of our EIT students. So just so we could have a seamless presentation, um, could you kindly just switch off any distractions or just turn off the notifications while the presentation is going on? And at the end of this presentation, you will get a copy of the slides and the video recording for this particular webinar. And just stick around till the end so you could be able to receive the link and the QR code for the certificate of attendance. And you'll have to just scan the QR code or use the link and complete a short survey, which will then lead you to where you can fill in your information to receive the certificate of attendance. So just to tell you a little bit about EIT. EIT is basically an engineering specialists with industry orientated programs, and this is made possible obviously by our world-class Australia accredited education with industry experienced lecturers that deliver a unique delivery mode for our programs that are offered here at EIT. Now, the reason EIT is the institute to choose is because we have been Australia's #1 provider for students' overall satisfaction, and we also top 3 Australian provider for quality of education experience, as well as top 3 for Australian provider for student support for postgraduate engineering programs. And then I'd just like to show you why that's evident, and that's obviously because of the awards we obtained last year. As you can see on the presentation slide, that in 2024, we received the Australian Export Award for International Education and Training, as well as West Australian Export Award for International Education and Training. And I'm going to give over the presentation to Dr. Hossein Tafti, and he'll be taking us through today's topic. And then a bit later on, after Dr. Hossein Tafti has presented, we'll be hearing from Andrew. Thank you all. Please take it away.
Hello, everyone. Thanks for joining this session. I hope everyone hears me well. And this is me. I'm Hossein. I'm based in Perth. I'm senior lecturer with EIT. Has been working with EIT last 3 years almost, and my main work and academic background and research background has been on electrical engineering, especially integration of renewable resources. And I'm going to go through some of the programs that we are offering as EIT and some of the basics of electrical engineering as a whole. The agenda for today, or my section, is what's electrical engineering, and then as part of electrical engineering, we go and talk about renewable resources and renewable energy, and some of the trending topics in electrical engineering. And then I quickly go through some of the programs that we offer, courses and examples of electrical tools that we are using at EIT to teach our students, and some of the career pathways that you could take after graduating from electrical engineering. Now, electrical engineering, everything around us, if you just look around where you are sitting in an office, in a room, wherever you look, all the appliances around you are electrical engineering, electrical appliances, and that is kind of uh, our life. It's taking our life, and it relates depending on the electricity itself. And some examples like your mobile phone, your laptop that you're at the moment using to watch this webinar, the trains that are becoming electronics and electrical trains, electrical vehicles, renewable resources that we have around us, motor drive systems that are being used in many appliances in your home, like washing machine, the air con, everything. So it's good to understand what are the basics of operations of these different sets of these sets of appliances that we are everyday using. And this is where electrical engineering units and courses are playing an important role. And we could talk about we could kind of classify this whole area of electrical engineering in 3 or 4 different branches. One is electrical systems or power systems that mainly deals with power system as a whole in high power plants, transmission lines, distribution systems that are bringing electricity or electrical energy from sources of uh, energy in power plants to you. In that sense, we could also consider renewable resources such as the photovoltaic systems, such as wind systems. All this come under the branch of what we call electrical power system. Another branch of electrical engineering and is electronics itself and embedded systems, which mainly deals with small electronic devices like such as mobile, such as computers, etc., communications between them, and also the basics of semiconductor materials, design of semiconductor materials, and how do we apply them for to get a smaller, faster, as well as more reliable appliances. They come under the branch of electronics. The third branch that we could think of electrical engineering is communications as well as electromagnetics. And in this case, we work with antennas, design of antennas, design of communication protocols to send data, fiber optic operation, and this part of this part of electrical engineering. And the last part, which is a bit of mix with what we call as industrial automation systems, is control. And here we are mainly focused on designing control algorithms to control different or to regulate different parameters, such as the temperature in your room or in your office, such as even the brightness of the screen that has a sensor and that has a controller in your computer, such as a controller of a electrical vehicle. And all this come under this fourth branch. At EIT, our main focus of the courses that we offer are on the electrical and power system and renewable integration. Of course, as an undergraduate, you also get to know and get imposed to other basics of other branches. But our main focus at the EIT is the power system, renewable resources, as well as high power applications. Uh, I guess we have discussed about this. Sometimes also computer systems are also considered as part of electrical engineering. I mean, the design of, I mean, if you think of a computer system itself, is a combination of electronics as well as programming. So electronic parts and design of electronic systems, processors, analog digital systems is part of electrical engineering itself. And as we discussed, it's used everywhere around us. So I can go to the next one. So on the electrical system and high power applications, we discuss about and we get to know about the basics and design principles and operations of power plants, including conventional power plants that are either coal-based or gas-based or even hydropower plants. How are we converting the main sources of energy to electrical energy? Then we also talk about telecommunications. Then we also talk about powering and lighting of houses, offices, and how do we now convert that electrical energy in the highest efficiency manner to the type of energy that we really need, like lighting, right? The lighting in our office. So that's the type of energy that we need, and how do we convert that? How is more efficient to extract the electrical, or sorry, convert the electrical energy or transform the electrical energy into the what we call as the last type of energy that we need in our specific application. These are all come under the electrical engineering. So looking at the technological growth that we have been we are having, let's say, in the last 2-3 decades, we could see an exponential growth in everything and every technology. Nowadays, everyone discusses and talks about artificial intelligence and its advantages. But in addition to that, we have many other technologies that are growing around us and may not be the focus of our attention. And the main trends that we have in this technological advances or advancements is either the equipments and components are getting smaller in size or lighter weight. Either their efficiency goes higher, either they are going towards a more sustainable solutions, such as, again, renewable resources that we have. And basically, as a human, we are looking for faster, smaller, and more reliable components and equipments around us. And that's where the trends on electrical engineering technologies moving on, right? So as one of these examples, we could think of smart grids that are a new, or not, I don't call it a new concept, or one of the latest advancements in electrical engineering. And simply, we are converting our conventional power system to a new system, which we call it as a smart grid. And as the name suggests, we add many measurements, many sensors, to get information of different points of our system. And by analyzing this information, we are achieving a more reliable and higher efficiency system, right? This is one of the concepts that is is at the age of technology in electrical engineering, right? So this is just as an example for your information. Um, Another example that we could see around us is our electrical cars or electric vehicles that are being increased in different countries. You can see the chart that we have here. And again, on electrical vehicles, there are different concepts, energy storage systems. What are different types of battery systems that could be used in electrical car, and how do we design them thermally, electrically, chemically, and how do we extend the lifetime of this battery system? That's one side of it. Then the other side is the power electron converters that are converting the stored energy inside the battery to a mechanical energy or to electrical energy, so that we can spin the motors or spin the drives in an electrical. That's another side of advancement in electrical engineering. The third one is the control of the system. How do we make sure the speed, if it is on like autonomous car, how do we make sure that the overall speed of the car stays constant? How do we make sure that extra smartness that we are providing to the car, such as moving between the lines automatically or stopping at a specific distance of the front car, etc. So these are again different advancements that we are getting in electrical engineering, and I want to tell you guys, not as someone that who is working and in electrical, yes, but as an ordinary person, that we are moving everything towards electrification, right? And as an electrical engineer, we have many areas to work to tackle, and that's one of the advantages of electrical engineering itself compared to many other engineering degrees. One of the reasons again is the renewable energy systems and the advancement that we have in renewables. Because of various issues that we have with conventional fossil fuel systems, such as extra greenhouse effects that we have in our atmosphere, or the lack of availability, etc. Every country in the world is moving towards the advancements and developments of renewable resources. As a general terminology, any source of energy that can be reproduced within the age of the human is called a type of renewables. That's why, for example, hydropower plants are considered as part of renewables. The solar and the wind, fossil fuels, and I don't know, the energy, different types of energy that we get from oceans, like wave energy, like tidal energy. They all come under the umbrella of renewable resources. There are types of energy that either they exist, and whether we use or do not use them, they still are being consumed, such as solar, or or types of energy that can be reproduced within the age of the human. They are unlike the fossil fuels. And integration of these renewables within the power system is making many challenges, even though as in general, everyone is happy. Everyone talks about integration of renewables and their advantages. But on the other side, we have many issues. We have many challenges in a power system by integrating renewables. And the main simple reason here is the fact that our power system has originally been designed for with considering conventional power plants. And now what we are doing, we are retiring the conventional power plants and putting our renewable resources. Our power system is not ready for that. Even though many governments, many um, uh, like planning or framework mappings that are existing around us are talking about about zero carbon power systems, etc. Our power system is not yet ready for that, and we as electrical engineers, or you guys as potential electrical engineers for future, have a lot to do, has a lot of areas of focus, a lot of areas of work to solve all these issues, so that we can get, or we can bring a sustainable life for our future generation. Everyone knows, I mean, I'm not talking about this map, because everyone knows that renewables are being increasing in the power system. So the future of electrical systems, uh, there are different areas, like as we discussed, renewable energy, higher energy efficiencies, robotics, design of robots that can be small and can be smart, artificial intelligence and its integration with the power system. How do we use that so that we can get higher efficiency, better reliability in our power system? That's another area. Nanotechnology and microelectronics, which are being used in designing of semiconductor materials, designing of better and smaller ICs, are trends or the futures that we have for electrical engineering. Guess we can skip this slide, as our trending ones are data and machine learning, and renewable resources, and different types of non-conventional energy systems. Now, let's discuss what we as EIT offer to potential students in different levels, and how can we teach you, and how can we provide you with this service of providing you with knowledge and expertise, so that you as an individual can contribute to achieving this sustainable future, sustainable source of energy for future. We have programs in different levels, starting from graduate certificates or vocational educational training that are normally online. For example, we have graduate certificate in renewable energy, which with the main focus on renewable energy. Students can get to know the basics of each of those systems, how are their operation, how do we troubleshoot those systems, etc. Then we talk about the undergraduate certificates, again, that are a bit or more advanced compared to our graduate certificates. Then we come to the undergraduate degree or bachelor degree, which is a 3 years bachelor degree here for us. And that starts from very basics of core units like mathematics, electrical systems, and it includes the design and concepts of electrical machines, renewable resources, and it goes through 3 years to an advanced topics such as big data analysis in power system, and power quality, and the ways we can improve the power quality of the power system. So this is what we are offering as Bachelor of Science. Of course, as you guys know, we are offering it both in online and on-campus modes. Then we have graduate certificates as the next level, which are pathways toward Master of Electrical Engineering. If someone doesn't want to do directly a Master of Electrical Engineering, our Master of Electrical Engineering, and as an example of units of Master, we can see we are focusing on power generation, transmission, power conversion, which deals with design of power electric converters and inverters. Then we also have like a unit on focus on renewables energy resources, which provides an advanced design and control of renewable resources. We also have a unit on safety and power system safety and protection, And it goes to an advanced topic such as substation design, power quality, and smart grids. So these are like as an example of units that we are covering in the Master of Electrical Engineering. And for those who want to go more advanced and want to design something new, they want to improve some of the research problems that exist in the literature in the field of electrical engineering. We are also offering a doctorate degree, and that's a 3-year doctorate degree, including some units plus, of course, a big research project in which the students focus on very specific, detailed, and very much in-depth topic, and analyze what are the research gaps and problems that exist in the industry and current literature, and they come up with some solutions with those for those problems. We also, in addition to that, to these courses, we also offer professional certificates and advanced diplomas, and they target specific subjects, such as we have professional certificate on lightning and earthing. If someone, for example, is working in that specific area, or they want to gain knowledge on that, how do we simulate those systems, etc., they can just enroll on this specific professional certificate, and they get experience on that side as well. We are offering many different professional certificates that are available also in our website on electrical engineering, and I've just mentioned one example of that. The other examples you could see, we have professional certificates on energy storage systems, fundamentals of electric vehicles. We have professional certificate on hydrogen, on those who are interested to understand hydrogen, how does electrolysis and fuel electrolyzers and fuel cells work. They could enroll and get knowledge on those. We also talk about different standards in those professional certificates, such as AS 3000, which is mainly applicable for Australia. So there are a big range of professional certificates available for those who might be interested. On advanced diplomas, we have again quite a good range on electrical engineering, on renewables, and on applied electrical engineering for power industry. And again, you can see the list here. The advanced diplomas are also accredited under the TEQA and TEXA, I think. And yeah, you can see the website for the list of those advanced diplomas and professional certificates, and browse your interest. As an institute which focuses on providing hands-on experience for students, we teach and we include many softwares in all different units. And this is something I tell on by the bottom of my heart, because that's I kind of sometimes I teach in some other universities and compare them with here with EIT. What other universities or conventional universities are doing are more focused on knowledge and theories. What we do here at EIT is more focused on applications and engineering basics. And that's why we are including this big list of softwares that you can see. And as a person who pursues bachelor, for example, or master, on almost every single unit, you are exposed to as one of these software tools, such as ETAP, PSCAD, Python, Power Factory, which is everyone knows is a software tool being used in many consultancy power system operators. We are having assignments on Power Factory, for example, in different units. And some other software tools like PSSE, Homer Pro, again, a famous software tool that a lot of us are using in industry. So this is our focus. Every single unit that we teach includes either of these software tools. And that's where you gain a real hands-on experience and apply the knowledge that you get, the theory that you get during a unit on a real system or on a model system. In addition to the software tools, as a student for, let's say, bachelor or master, you have some mandatory hands-on workshops. Either you can get exempted from them if you have extensive work experience and you provide us with evidences of your work, or you are required to attend these workshops. And for example, these workshops that you can see some of the figures, some of the pictures here are 3 weeks of condensed workshops every day, and they provide the students with hands-on experience on almost each all of these different topics and basics that we discussed. They start from very basics of simple measurements onto control of robots, onto design of PLCs and using of PLCs to controlling different systems, and power system protection, motors, etc. So in these 3 weeks, the students really get that hands-on experience if they don't have the current work experience. Potential job outcomes. Again, a lot of industries we discussed: buildings, manufacturing, mining, oil and gas. And in all these different sectors, nowadays, the focus is either integration of renewables, either integration of energy storage systems, either integration of more advanced and more higher efficiency systems. And this is where we get. And we have many graduates that are already working in industry, and you could refer to our website for their stories that are available. And but by this, I will end my part of presentation, and hopefully Andrew can take from here and provide us with his story about EIT. And thanks everyone. I will be around if there was any questions at the end of the session. Thank you very much, everyone, and all to you, Andrew. Andrew, you are mute.
Yes, I know. Just bringing it back online. Sorry for that. I think
That's all good.
I think we need to bring that back to that one from a sharing point of view. I'm not too sure about bringing that up on the big screen though. But let me just. I'm not too sure. Maybe easier for me to share from here on my screen.
Andrew, we are seeing the screen. It was okay. If you unless you are sharing your screen also, that's fine.
Sorry, is that actually sharing okay? Yeah.
At the moment, we are not seeing your shared screen.
It should be coming through.
Yeah, there we go.
Yeah, it's just coming through now.
We can see it now. Yeah.
Okay. Yep.
Thank you.
Okay. Well, thank you to EIT for the opportunity to talk from a student's point of view. And I think it's probably easy for me just to actually talk through the reality of my EIT journey as such. And I think it'll probably give you some insight in regards to the how good the experience ultimately was and how much I actually gained through it, and more so where I was in regards to where I was from a career point of view. Just going to try and get this to go to the next slide for me. Okay. Ooh, let's just jump a little bit too far. Okay. So obviously you're all people in different stages in your careers now and looking to from a further educational point of view. I actually started as an electrical fitter mechanic, an apprenticeship in Australia, worked in an elevator company installing and servicing elevators. An incredible journey in that regard, a great industry, have been in it literally for 40 years and that's such. And over that journey, went into senior management and everything else like that. But there's a reality from an educational point of view. So after 25 years of being in that industry and going then into consultancy, specializing in vertical transport, there was a very harsh reality for me that I only had trade qualifications. I was definitely recognised as a system expert within the world of Conne elevators, and I studied and carried out major project works in the Conne test towers and R&D centre, and did a whole lot of works in that particular space. But then you actually realise that ultimately, even though internally those qualifications are recognised, they're not recognised outside of industry. And that was the real trigger point for me. So in 2016, started my journey with EIT. So the logical first step for me was an advanced diploma in applied electrical engineering. And I think there was, like I'm saying here, there were two big takeaways. Firstly, I think when you connect with a chosen qualification pathway, the process of actually learning and growing your knowledge and definitely your skill set in that is very rewarding, because it's very much, as Dr. Hossein Tafti just said, it's very much about an applied and application of it. The duration of 18 months for an advanced diploma I felt was quite short. And I definitely felt before I started that I could achieve this qualification. And there was a natural flow on from that experience, and it was a very good experience. That the decision to say to go into my bachelor's of science was a very easy one. Now, I'm not going to say that it wasn't challenging. There was definitely times when I was tested academically. There was definitely a major growth in learning and the ability to research in that area. And I feel that through going through that journey, that resilience value is something that you definitely achieve. And that was a balance between study, actually working, and I run my own business at the same time. So there was a lot to juggle, but you do hone a skill in your time, in your time management, so to speak. I think the need for recognised qualification, has been said, is that there's a lot of information in regards to the sheer growth of electrical engineering across all major cities and countries. There's just no doubt about it, and there's going to be a doubling effect of it in that. And obviously in vertical transport and elevators, then very, very much connected to that in major high-rise buildings and alike. I think within Australia and through the recognised qualifications, the advanced diploma allowed me to become an associate member of Engineers Australia. That allowed me to become recognised in the National Engineering Register. And in New South Wales, there's a Design Practitioning Act, and it allowed me to become a design practitioner for vertical transport, as per saying the New South Wales Building Commissioner. Then studies definitely opened my eyes, because we can get a little bit focused on where we are in any one particular time, especially with regards to maintenance of electrical systems. And I think studying elevators for a long time and being involved in it, but then seeing actually in electrical systems and power generation distribution, it actually opened a lot to me. And then I actually had the ability to take that on board, look at what we're doing in the elevator industry, and create a product actually branded as Maple, which is a maintenance assessment program for lifts and escalators. And so released this as I completed my advanced diploma. And then as a direct result, and that was a direct result of my studies, actually, and the insight that I got from it. Now, that product is a product that very much exists today. It's adopted nationally with major property owners of major high-rise buildings and shopping centres and hospitals and everything else like that. And it's recognised as one of the leading vertical transport products when it comes to maintenance specifications. And I think so. If you've got the question, does study actually just remain in EIT or in whatever location you are? Absolutely not. Can you actually really change and create real world difference through your studies, from my personal point of view and experience, 100%. And I would urge everyone to take that step into that area. Then tools, absolutely. I think the EIT journey, and I've just listed a whole lot out there, use so much different software, and use it in very real applications. And definitely, like and even going back, from writing in different codes in regards to what we, from C into Python and the rest of it like that. Definitely use a lot of PS/CAD and Power Factory, then a whole lot of other building blocks actually all the way through that journey. And I think the takeaway from that is that you get very good at being exposed to newness, the things that are new, and it takes you out of your comfort zone. And so you develop an ability to actually process information a lot faster, and actually use that information, and you can actually drive real outcome through it. And so I think where you may be set in a certain way, or you may actually have some limitation or limited comfort zone in regards to actually embracing new software, new applications, etc., like that. It breaks that barrier down. So, and I think it's very important because the rapidity of change in our industry today has probably never been so intense in that regard. Then, okay, the question of how combined skill and knowledge for both courses impact the confidence performance in the workplace. And he said, absolutely. I said, there's an empowerment, I believe, in education. And I think the biggest single takeaway isn't the fact is that often we know about technology. You probably know about wind turbines. You probably know about hydro. You probably know a lot of things in the current workplace that you may be at now. But I think it's through the very deep dive of education is that it comes down to a place, or what I'll call a position of independent comprehension, that you actually know things, not just by how they function and observation, but you know it by the design. You know about the very construction as to why things are the way they are. And that is an incredible point of empowerment, because you don't ever have to accept someone else's opinion or advice. You actually get very grounded in being able to learn independently and to research independently, and create a very strong foundation for going forward in your careers. So I work in a bit of an abstract industry of vertical transport, and as such, but I can assure you that when it comes into the urbanisation of cities, just the sheer growth of cities and everything that we have, that there is so many, the growth factor, the new developments, the initiatives, the change of technology, the change in how we, from a sustainability and an eco point of view, and about how we connect with vertical transport throughout cities, from transit into retail, into office, is unbelievable in how much that is changing. And so I believe the only way that anyone in this modern world can keep up with that is you need to invest in yourself. You need to continue to invest in yourself, and truly, it will sort of, if we all do that collectively, then I think we're building the better society that we really want for future generations. And there is no doubt that a better society is completely anchored in electrical engineering. And I think I've partnered now technically as a student, and a very humble student at that. But EIT have been invaluable to me pretty well over the last decade. And I'm extremely thankful for the great team there, and to the professors and lecturers that share their knowledge. It's been an incredible journey, and I think you should all seriously consider going on that journey too. So thank you for your time.
Thank you, Andrew, and thank you, Dr. Hussein, and thank you to all our attendees. That was very insightful. If you don't mind, can I please take control of the presentation once again? Thank you. Sorry, just having a bit of a lag in my system, but it is coming up now. Just waiting for it to load. But anyway, I hope our attendees found this very informative and insightful because, I mean, I'm not an engineer, but I did. So thank you, Dr. Tafati and Andrew. We do appreciate your time. Please just quickly hold on while I go to the relevant slide. Okay, so do we have any questions right now from any of our attendees? I'll give you guys 5 minutes to type the questions, and then if not, we can move on. Yeah, I don't see anyone typing any questions, so I guess we can wrap it up if there aren't any questions. So basically, we've got a little bit of a competition running. Basically, you just need to showcase your creativity and humor in a video format for a chance to claim the grand prize of 2,000 US dollars. And if you are one of the 10 runner-ups, you will get 100 US dollars. So basically what you'd have to do is just create a clever twist on a traditional tool or a hilarious automation idea. And it just needs to be 3 minutes, and that could basically get you $3,000. I mean, $2,000. Sorry about that. And then, as I had said earlier on, that I will provide the certificate of attendance, QR code, and the link. However, oh, I see there's a question here. Which is the best to take between Master of Electrical Systems or Masters in I believe maybe they're trying to say industrial automation. Dr. Tofati and maybe Andrew, do you guys want to take that?
I guess it all depends on the area that you are working. I mean, the experience that you have and your main interest. Both of them has some commonalities, there are some common units between them as well. But I mean, it really depends on which area you are interested in or you are working in. I don't really see any other factor in making that decision other than the area that you are working and the interest that you have. Good luck with that.
Thank you for that, Doctor. And then we've got a question from Maxwell Chima, and Maxwell is asking, can international students for online masters in engineering attend the workshop in Australia? Unf
The
uh,
the answer
okay,
to the part that I know is yes. Uh, but yeah, so depending again, if you have a work experience already, you could get exemption and you could apply for the prior learning or RPL. But other case, you could come to Australia, and we have had cases of students who came from different countries for the 3 weeks of workshop here. Hopefully that
thank you
helps.
for that. Thank you for that, Dr. Hussein. And then the next question we've got from Mutwing Sibela, and they're asking about the Master of Electrical Systems. Does it not have electives to take some of industrial automation modules?
We have recently added that to our electrical engineering or master of electrical engineer power system, and there are I think 5 or 4 units from industrial automation that are added as electives. So you are welcome to take those elective units if you are interested. And those units, in the units that we have from and industrial automation include a unit on AI, a unit on control systems, a unit on PLC design and control, and we also have a unit as an elective from Master of Mechanical Engineering, which is on green hydrogen for electrical vehicles or fuel cell vehicles. So we have kind of a pool of electives for those who are interested.
Thank you for that. And then the next question is from Edgar, and Edgar's asking, or rather saying that uh, currently I have studied metrology and standardization engineering. Can I take masters in instrumentation engineering?
I guess here again, correct a better wording for instrumentation engineering. Most probably, you meant industrial automation, and there are the criteria of eligibility for entry to industrial automation is a bit of broad. We could have people from different backgrounds, and I think you could potentially be fine with that. But again, all the applications or all those cases are analyzed on a case by case. So yeah, good luck with that.
Thank you for answering that question, Dr. Tafati. And then we've got the next question from Depesh, and Depesh is asking, is there any scholarship opportunity for international students for master in electrical system? So yes, we do offer scholarships and bursaries. However, they're not fully funded. So basically what that means is that should you be accepted for the scholarship or the bursary, you will basically be given a percentage of the fee amount. So that's how it works. You'd have to apply for that based off the merit of your previous academics. Is there any other questions? Let me just check the Q&A box. Okay, I have answered the other ones earlier on. And then the other question is, does the scholarship apply for online master course as well? So our scholarships and bursaries, they apply to all our programs except for the professional certificates of competency, as those are 3-month short courses. Depending on where you are in the world, it should cost you no less more than, no more than $1,000 for our professional certificates. And then, does the scholarship apply? Yes, okay, I've responded to that. Let's just check if we don't have any more questions in the Q&A. And it seems like we do not. And I have provided the links to the certificate of attendance, as well as if you'd like to speak to a course advisor, there's a link there to book a call. And so they can reach out to you and discuss whatever it is you may want to speak to them about. And then we also have a link there for our other upcoming webinars. So this week is our virtual open week where we discuss different topics and so forth. So if you could just check that, maybe you might find something that will interest you. And lastly, we also have a link to all the courses we are offering at EIT at the moment. And I, I'm I'm checking, and we still don't have any other questions. So if there's nothing else, you can just take a look at our our contact information. So that's our website, as well as where our head is located, and how you can get a hold of us via telephonically, as well as through the email. And I have provided the course schedule link as well. So if we don't have anything further, we may call it a day, a night, or afternoon, once again, depending on where you are. But thank you all for your attendance. And Dr. Tafti and Andrew, thank you for your guys' time in informing us today. We truly appreciate it. Have a good day. Bye.
Thanks, everyone. Thanks, Kuman. Thanks, Andrew. Thanks, everyone.